Heat transfer notes. The definition of heat transfer is the movement of energy from an object that has a high temperature to an object with a lower temperature. Usually when we have a heat transfer problem in class, there will be two objects involved. One object will likely be water or some type of liquid, and the other object will be a metal or some type of heated solid. During a heat transfer reaction, one item loses heat while the other item involved gains the heat. This means that the Q, or the heat change of one item, is the opposite or negative of the Q of the other item. In heat transfer, both items have different starting temperatures. However, both items will have the same final temperature. This also means that when you're finding the change in temperature for the items, both of them use the same final temperature. All right, we're going to look at each of the variables that you became familiar with last week, Q, M, C, and change of T, and see how each of them is affected during a heat transfer problem. First off, now we have two objects. So we're going to have to account for two Q equals MC change of T problems. First, the Q. The Q of one object will be calculated. This means you will have the mass, you will have the specific heat, and you will have the change in temperature of that one object. You always have to do this first. The Q for the second object will be the opposite of the Q of the first object that you solved first. Therefore, as an example, if the Q for your water is 365 joules, then you know that the Q of the metal or object involved is negative 365 joules. Notice they're equal, but opposite changes in heat. All right, let's look at the other variables. M, mass, is unchanged. Mass will be given for one or both of your objects in the problem. If only one mass is given, this means you will be asked to find the mass of the other object. Remember, mass must always be positive. Now, specific heat, or C. This is the same as mass. There's no change. One or both will always be given in a problem. If one is not given, you will be asked to solve for it or find it. Now, since this is not the first time we're doing specific heat problems or calorimetry problems, now I will expect you to know the specific heat of water because you will have to, it will be a recurrent constant. So always remember the specific heat of water is 4.184 joules per grams degrees Celsius. Finally, change in T, your change in temperature. Change in T formula does not change. It is still final temperature minus starting temperature. Both objects will have the same final temperature, but their starting temperatures will be different. If you're not given a starting temperature for an object, you will be asked to find that object's change in temperature in the problem. All right, let's do two practice problems. The first one reads, Alex is working in the lab with a beaker of water that has a mass of 63.7 grams. The water's temperature is 23.6 degrees Celsius. If he adds in a piece of metal that has a mass of 65.6 grams at 98.7 degrees Celsius, the temperature of the water and the metal both become 29.1 degrees Celsius. What is the specific heat of the metal? Well, last week we did problems that involved only one object, and I had you write the four variables and then read the problem again and try to identify each of the four variables and or three variables and the missing variable that you were solving for. This week it's a little different because we have two objects, but the way that you're starting these types of problems is the same. I still want you to write out each of the variables, but notice the difference. In the first line, we have Q, M, C, and change of T, but the little subtitles next to each of the variables tell me what object I am talking about. So the first one says Q water, M water, C water, and change of T water, right? By organizing it this way, my variables will not get jumbled up. Therefore, the next line says Q metal, M metal, C metal, and change of T metal. Please organize your problems in the same way. All right, so we're going to read the problem again. Try to identify all of the things we're missing. So, Alex is working in the lab with a beaker of water that has a mass of 63.7 grams. Therefore, this is your M water, 63.7 grams. Now, the water's temperature is 23.6 degrees Celsius. Remember, each object's starting temperature will be different. Therefore, 23.6 degrees Celsius is my T initial for water. If he adds in a piece of metal that has a mass of 65.6 grams, this is my M metal, 65.6 grams, at 98.7 degrees Celsius, this is my starting temperature for the metal. What was the specific heat of, skipped a line. The temperature of the water and the metal both become 29.1. So if you look at the change in temperature for both of the objects, my ending temperature is the same, 29.1. But I can find the difference in either one. So now I have the change in temperature of the water and the change in temperature of the metal. Finally, the only other thing that we know is the specific heat of water, 4.184 joules per grams degrees Celsius. And the question tells us, what is the specific heat of the metal? So under C metal, I've put solve for it, because that is what I'm going to have to solve. The other two unknowns, which I don't know, are the Q's. All right, so once you've done this, the next thing that I want you to do is look at each object and try and figure out which one you know more variables for. So if we just look at the water, we don't know the Q, but we know the M, water, we know C, water, and we know change of T of water. If we look at the metal, we don't know we don't know Q, and we don't know C. So my first step is going to be to focus on solving for the Q of the water. And if you remember correctly, Q equals M times C times change of T. So I'm simply multiplying 63.7 All right, so if you remember correctly, Q equals MC change of T. So I am going to take 63.7, which is the mass of the water, multiply it by the specific heat of water, 4.184, and multiply it by the change in temperature of the water, 5.5 degrees Celsius. This gives me 1,465.8644 joules. However, I have to round it to 1,470 joules due to the three significant figures that I see recurrent in this problem. Once I've figured out what the Q of the water is, then I know the Q of the metal. The Q of the metal is the opposite of the Q of the water, so it has to be negative 1,470. So now my next step is going to be to plug in everything that I know for the metal and solve for the C of the metal. Therefore, I know the Q, negative 1,470 joules. I know mass of the metal, 65.6 grams. I know the change in T, which was negative 69.6. I don't know C. So my first step is going to be to multiply those two together, the mass and the change in T. That gives me negative 4,565.76. And then I'm dividing both sides by the product. So that gives me my C, which is 0.32196 joules per grams degrees Celsius. And then I also have to round to 3 due to the recurrent 3 significant figures in this problem. So my actual C for the metal is 0.322 joules per grams degrees Celsius. Let's try the next one. Kyle has a jug of water at 24.3 degrees Celsius. He takes a piece of metal that has a mass of 56.7 grams and a specific heat of 0.15 joules per grams degrees Celsius and a temperature of 103.4 degrees Celsius and places it in the water. The temperature of both become 28.9 degrees Celsius. What is the mass of the water? We'll set this up the same way we did the previous problem. And I know that I've already written down what each of the quantities are that correspond with these variables, but I want to take this slowly. So, pretend that I've just written out the variables for the water and the metal. Now I'm going to read the problem again, and I'm going to identify each of those variables. So Kyle has a jug of water at 24.3 degrees Celsius. This is Kyle's initial temperature for the water, 24.3 degrees Celsius. He takes a piece of metal that has a mass of 56.7 grams. This is my M metal, 56.7 grams, and a specific heat of 0.15 joules per grams degrees Celsius. This is my C of the metal, and a temperature of 103.4 degrees Celsius. They've also given us the initial temperature of the metal, 103.4 degrees Celsius. The temperature of both becomes 28.9. So you can see in the change in temperature of the water and the change in temperature of the metal that I've used 28.9 degrees Celsius as my final temperature for both. So now I can calculate the change in temperature for my water and the change in temperature for the metal. I also know that I'm going to have to solve for the mass of the water. And I can fill in the specific heat of water, which I know is 4.184 joules per grams degrees Celsius. Therefore, the three variables that I need to solve for are the Q of the metal, the Q of the water, and the mass of the water. Alright, so now we're going to do the same thing we did in the previous problem. I want you to look at each of the variables and tell me which one, or each of the objects, and tell me for which one do we know more quantities. So for the water, we know the specific heat and the change in temperature. For the metal, we know the mass, the specific heat, and the change in temperature. So the first step is going to be finding the Q of the metal. Again, to find Q, you multiply mass times specific heat times change in temperature. Therefore, I'm multiplying 56.7 grams by 0.15 joules per grams degrees Celsius times negative 74.5 degrees Celsius, which was the change in temperature of the metal. This gives me negative 633.6225 joules. But I have to round it to two significant figures because of the 0.15 joules per grams degrees Celsius. Therefore, my answer is 630 joules. Negative 630 joules. And because the Q of the metal is the opposite of the Q of the water, then I know the Q is going to be 630 joules. So now the only thing that I have to solve for is the M of the water, the mass of the water. So I write down all of the quantities that I know,